This video is a review of exponent laws for the exponent quiz. So in 1, 2, 3, and 4, we want to evaluate. So in number 1, we have the parenthesis of -7 squared. So this is really -7 times -7, which is going to equal 49. In number 2, we have parenthesis -6 to the -2nd power. So because it is a negative exponent, we need to move it into the denominator. So we have 1 over -6 squared. Then we can square our number and we get 36. In number 3, we have -5 squared. So that really is -1 times 5 squared. 5 squared is 25, so we have -1 times 25, which is -25. In number 4, we have 10 squared, which is 10 times 10, which gets us 100. In the next problems, we want to simplify the expressions completely, leaving no negative exponents. So in number 5, we have negative h to the 0 power. So this h to the 0 power becomes 1, but with that negative sign there, we're going to have -1 times 1. So this simplifies to -1. In number 6, we have 12 times parenthesis x to the 5f y to the 10g over z to the 15h to the 0 power. So all of this in the parenthesis has the 0 exponent, so that's going to become 1. So we have 12 times 1, which is 12. In number 7, we have 8 squared times w to the 0. So w to the 0 is 1. So we have 8 squared times 1, which is 64 times 1, so we get 64. In number 8, we have -5 to the 3rd power times 10 to the 0. So 10 to the 0 is 1. We have -5 to the 3rd power times 1. -5 to the 3rd power is -5 times -5 times -5, which gives us -125 times 1, which is -125. In number 9, we have 2x to the 0 times -2x to the 0 times parenthesis 4x to the 0. So x to the 0 is going to become 1, so 2 times 1 is 2. -2 times x to the 0, the x to the 0 becomes 1, so -2 times 1 is also -2. And then the last one, everything is in parentheses here, so that just becomes a 1. So we have 2 times -2 times 1, which gets us -4. In number 10, we have 5f to the -12. So this is a negative exponent, which is in the numerator and needs to move to the denominator. Remember that the f is separate from the 5, so the 5 is going to stay in the numerator on top of the fraction, and the f is going to move down and become a positive exponent. In number 11, we have two variables with negative exponents. So the f is going to move to the denominator, and the h is going to move to the denominator. G is positive, so it's going to stay in the numerator. So we have g to the 9th over f to the 3rd, h to the 6th. In number 12, we have 12 m to the -6th over 15 n to the 12th and q to the -3rd. So 12 and 15, because they do not have exponents, they can be reduced. Both of those numbers are divisible by 3, so we would have 4 on the numerator and 5 on the denominator. If we look at our variables, n is a negative exponent, so it's going to need to move down. Q is a negative exponent, so it's going to need to move up. So on the top, we would also have q to the 3rd, and on the bottom, we would have m to the 6th and n to the 12th. In number 13, we have 3 f bases with different exponents, so we're going to add those exponents together. So we have f to the 4 plus 10 plus -3, which gets us f to the 11th. In number 14, we have 12x to the 5th times 5x to the -8th. So these two numbers that have no exponents can multiply together. We have 12 times 5, and we're going to add the exponents, so 5 plus -8. So we get 60x to the -3rd. Because x has a negative exponent, it needs to move down, so we would have 60 over x to the 3rd. In number 15, these numbers 2 and -3 have no exponents, so again, they can multiply together. Our x bases, or x exponents and y exponents are going to add together. So for x, we have 3 plus negative 22. And for y, we have 8 plus 15. So we get negative 6x to the negative 19th, y to the 23rd. Remember that we can't have negative exponents, so the x is going to need to move to the denominator. So we have negative 6y to the 23rd over x to the 19th. In number 16, we have an exponent of 5 that we are going to distribute. So 4 did not have an exponent, so it now becomes 4 to the 5th. Remember, we want to leave our number in parentheses until we evaluate. And then we have a to the 9x times 5, b to the 3x times 5, and c to the x times 5. So in our calculator, we can do 4 to the 5th power, which gets us 1024, a to the 45x, b to the 15x, and c to the 5x. In number 17, when we distribute our exponent, we would have 8 to the negative 2 times x to the negative 5 times negative 2, y to the negative 7 times negative 2, and z to the 3 times negative 2. So we would have 8 to the negative 2, x to the 10th, y to the 14th, and z to the negative 6th. So 8 and z have negative exponents, so they're going to have to move down. So we have x to the 10th, y to the 14th over 8 squared z to the 6th. Remember that 8 squared we can evaluate. 8 squared is 64, so we have x to the 10th, y to the 14th over 64z to the 6th. In number 18, we have this parenthesis where we are going to distribute our exponent. So we have 8a to the b times 2 to the 3rd, a to the 4b times 3, and x to the 3 to the m times 3. So we have 8ab, 2 to the 3rd is 8, so times 8, a to the 12b, x to the 3m. Now 8 and 8 have no exponents, so they can multiply together. So we'd have 8 times 8. And then for the a exponents, we have 1b plus 12b, and then x to the 3m. We would get 64a to the 13b, x to the 3m. In number 19, we have a w on top, which has an exponent of 1, and a w on the bottom, which has an exponent of 12. So when we are dividing with our exponents, we are subtracting and putting them where the larger base is. So 12 is the larger base. So on the top, we're going to have 1, and on the bottom, we're going to subtract 12 minus 1 in the exponents. We get 1 over y, or w to the 11th. In number 20, we have a negative exponent, so we want to move that first. So when we move it to the bottom, we have 5 x to the 5p and 8 to the x to the 8p. Now, because they're on the same level of the fraction, we're not going to subtract, we're going to add. We have 1 over x to the 5p plus 8p. So we get 1 over x to the 13p. In number 21, we want to treat each variable separate. So for m, the larger exponent's on top, so we're going to subtract 12f minus 3f on top. For n, the larger exponent's on the bottom, so we're going to subtract 30g minus 19g. So we get m to the 9f over n to the 11g. In number 22, we can divide these numbers both by 6 to reduce. So we have 6 over 5. When we look at the v, the larger exponent's on top, so we're going to subtract down the top. So we would have 6v to the 9th over 5. In number 23, we have 3 negative exponents. The 2 x's need to move, and the y on the top needs to move. We have negative 8 x to the 20th over x to the 15th, y to the 5th, and y to the 17th. So for x's, because they're on different levels of the fraction, we are going to subtract their exponents, which where the x is larger on top, we have negative 8 times x to the 20 minus 15. Because y's are both on the same level on the bottom, we are going to add their exponents. So we get negative 8 x to the 5th over y to the 22nd. In number 24, we have a couple with negative exponents. We are going to move those first. So the y is going to come down and the a on the bottom is going to come up. So we have a 8 to the 8m times a to the 2m over y to the m. Because there are two a variables on the same level, we can add those exponents. So we have 8m plus 2m. So we get a to the 10m over y to the m. In number 25, we need to distribute this exponent to everything. So we have parenthesis negative 2 to the 4th, x to the 5 times 4 over y to the 8 times 4. So negative 2 to the 4th is 16, x to the 20th over y to the 32nd. In 26, when we distribute our exponent, it's a negative 2, so we have negative 4 to the negative 2, x to the 15 times negative 2, y to the 7 times negative 2 over 8 to the negative 2, x to the negative 10 times negative 2. So we have negative 4 to the negative 2, x to the negative 30th, y to the negative 14th, over 8 to the negative 2, x to the 20th. So everything except for the x to the 20th is going to move. So on the top, we would have 8 squared, and on the bottom, we would have negative 4 squared, x to the 20th, x to the 30th, y to the 14th. So we can square these numbers. So we have 64 over 16. When we add the x exponents, we get x to the 50th, y to the 14th. 64 and 16 can both divide by 16, so we would have 4 over x to the 50th, y to the 14th. And the last part, we are going to simplify. Here, we are going to combine like terms because we are adding and subtracting. When we combine like terms, it's the same variable to the same exponent. So here, when we subtract, it's just 8 minus 10, which leaves us negative 2, x to the 4th. The x is not going to change. We're just combining how many we have together. In 28, the x to the 10th can combine. So 4 plus 8 is 12, x to the 10th. And the 5x to the 4th is going to stay by itself because it has a different exponent.